stateful knowledge session. So in the contradictory to the stateless knowledge sessions, this is the one that is going to be most commonly used because in real world scenario we are going to fire a lot of rules. We are going to fire it iteratively. We want modification in a particular fact to be made available for the other rules. So all that is made possible by the stateful knowledge session because the data it's a long living session. If it's for a monitoring purpose that you're doing or some sort of thing which happens iteratively and it has to be it has to live longer and it's not just like one time execution. The data can be inserted multiple times. The fact can change in the working memory time and again, and the rules needs to be fired. All the rules needs to be fired again and again. Then in those sort of scenarios, then we will go for the stateful knowledge session, and this is the most commonly used session as well. The stateless knowledge session is used only when we need to do some one-time execution tasks and we need to get some things validated, a result obtained from a particular rule execution. Then we go for the stateless stuff. And here, since this is the most commonly used one, the object is named as KI session itself. In the stateless thing, the object was named as stateless KI session. Herein, it is named as KI session. That's it. And KI session means it's a stateful knowledge session. And then see there is a command fire all rules. That's the one which is going to fire all the rules on the data that is present in the working memory at that point in time. So this command was executed automatically in the stateless knowledge session. Herein we need to do it explicitly. In the knowledge thing, we executed just the command execute, and that was responsible for firing all the rules. But herein, it will not fire automatically. You need to tell the rule engine when to fire all the rules to so that the rule engine can apply all the rules on the data that is present in the working memory at that point in time. So that's our job to do, fire all rules command, and that's one big difference between the KI session and the stateless KI session. And also here we need to take care of disposing the knowledge session. We need to call the dispose method on the KI session object once the task is done, once we have executed all the rules. If we don't do that, then it's going to keep leaking memory. KI session, as I said, it's a runtime object, so it's going to interact with the rule. It's going to interact with the rule engine. It's going to interact with the core engine, the process engine, and the rule engine of jBPM and Drools. So that object is going to have resources in the server because it interacts directly with the server engine. So we need, whenever the task is done and the KI session object is no longer needed, then we need to dispose that object by invoking the dispose method. And in stateless KI session, that was not required to do. But herein, yes, we need to do that. So otherwise it's going to leak memory. Okay. So there is this example that is part of this out of the box example that they've given. It's a very good example to understand a lot of stuff. We will be going through that example rule file and then seeing what it actually does. So the important thing to note is in the previous example, even though we inserted multiple instances of data, we only had one object there. We only had the claims object there, and we were able to execute in a batch mode two commands of that is two particular instances of the claims object. But herein there might be a scenario wherein we need to look at the scenario. This is not anything particular to stateful or stateless, but this is more on the fact model. How a rule engine actually works when there are multiple instances of multiple objects. When the object, there are two object types and there is one instance of each object type, then how does the rule engine work? So that's one thing. And if the objects are related to each other, and that relationship has to be explicitly specified in the rule engine. The rule engine is not going to understand the internal relationship. If I say a class has another class, if there is an has a relationship or is a relationship between classes, that's not going to be understood by the rule engine by default. We need to make it understand that these two classes are interrelated, they are linked, they have a relationship. And that relationship is established using the binding variables in the constraint section. Here we saw that we are used in the constraints in the field constraint section, we use literal value. So that's how we evaluated our rules. But when we have the objects coming, and then if an object is related to another object, and that needs to be specified in the rule, then we need to make use of the binding variables that we create within the rule in the constraints part, in the field constraints part. So in the field constraint part, we are using a binding variable. So here in $room, this is going to be one of the binding variable, and that binding variable, see, this $room is bound to the actual room object, which is the fire object. So this fire object is going to contain a room object, and that room object is bound to the variable $room. This is the binding variable, and that binding variable will at last be used. So this itself is not a condition, it's just that fire is going to have a room. So any fire object that comes in should have a room, and that room object has been bound to the variable $room, and that $room is going to be used here in a condition check in a field constraint. So we are using the binding variable as part of the condition itself. So whatever room object came here, we are checking whether the sprinkler object also has the same room object. So to make sure if the fire is in a particular room, then the sprinkler should be on the same room where the on was false, and that's what we are going to do. Turn on the sprinkler for that particular room where the fire is there. So this is how this is how we would be able to establish relationships between objects within a rule. Otherwise, it's going to be simply impossible because for the rule, it's going to be a very generic rule here. We have written very declaratively and a very generic kind of a rule here. If it has to apply on objects that are working together, if there is a relationship between those objects, then that needs to be specified. Otherwise, it's going to work on all the combinations of objects that is present in the working memory at that point in time. This is very important to understand. See, the rule engine does not understand like a Java method. See, in a Java method, we would be passing particular instances of objects, and then we would be executing the code. So the code knows what is the object instance that it is working upon. But in the rules case, it is a generic rule. Any object can be applied. So the rule engine, what it does is it applies all in a particular rule. If there are two objects that are being used, then it uses all combinations of the two objects that is present in the working memory at that point in time, regardless of whether those two objects are related or those objects are totally part of different objects. It doesn't care. It just makes use of that. So to limit and then to execute the rule on only related objects or only the objects that has got relationship with each other. Because see here there is a fire and the sprinkler. So if there is fire in a room, I cannot sprinkle on all the rooms that is available. I need to sprinkle on only the room that is having a fire. So I need to do the condition check where is that happening. So that is being done using the binding variable. Otherwise, the sprinkler would be executed on a different room where there is no fire at all. So we need to find out which room has got fire, and that's the only way to do it. Now we'll see this whole rule in the code, and then we'll explain what it does. So this is the one that we are going to see. These are the import statements that we will be using. So we have defined all our model objects that we have created. Model object should be here. Alarm Java. Alarm is nothing, it's just an alarm. Fire is going to contain a room object. House are going to contain rooms. So house is going to contain a list of rooms and a list of sprinklers. So initially we have 4 rooms that are defined, and the sprinkler is defined for each room, just like that. And fire is going to contain a room, and room is going to contain a sprinkler. Room is going to just contain a name, and the sprinkler is going to have a reference to the room object. So this is a basic data model, and this is an example out of the box of very good examples. I wanted to explain this to you guys. So let's see the first rule, what it does. So let's minimize the import section. So in the rule part, the first rule says when there is a fire, turn on the sprinkler. So herein, the first condition is house object. There is no field constraint here. We are just checking whether there is a house object there. So all the house object that is there in the working memory at that point in time gets this particular statement satisfies all those house objects. There is no constraint there. If it's just an object of type house, then this particular condition gets satisfied, and then that gets bound to a variable $house. And then we have the fire object. If and then fire object, we already saw fire is going to contain a reference to the room object. So the room object that comes in here, there is no condition check. There is no field constraint here. There is only binding here. The room which the fire is going to have an instance of, that is bound to the variable $room. This is the binding variable here. This is done so that it can be made use of in the subsequent condition checks. So this thing is fired. So why do we do that? Because we need to have a handle on the room where there is fire, so that we can instantiate the sprinkler on the exact room where there is actually fire. So only for that, or else there will be multiple rooms in the house where, and not every room is going to catch fire, and the only room that has fire should be sprinkled upon. So for that only we have bound this variable, and then we have got the sprinkler. We are checking whether the room that was evaluated in the previous statement is equal to the room that the sprinkler object has. See, this is what I want you to understand. These things can be multiple combinations. I can have 3 rooms, 3 houses, and each house having 4 rooms, and there are 3 fire objects, meaning there is fire in 3 rooms of any of the 4 houses, any of the 3 rooms, any of the 4 houses. And then I need to sprinkle on exactly the same 3 rooms on that particular, in whichever house the fire is there. So, but if I have these 3 objects in the working memory, I would explain the cross product, and then this example would become more easier to understand. But still, I wanted to have an overview, and then I don't want to go to the cross product first and then come here. First, let's see this and then go to the cross product. Even though it's somewhat tricky to understand, but uh, be patient to understand this. There are 3 objects here, and there might be many instances of these 3 objects here, and each object is interrelated to each other. House is going to have rooms, fire is going to contain a room, and sprinkler object is going to contain a room as well. So we need to actually, when the combinations happen, we need to find the right combination where the fire is, and then turn on the sprinkler for that particular room where there is fire now. So that's what they are doing. House is okay. Fire, they are getting the room variable to the $room, and if there is a and there is a sprinkler object, and each sprinkler object will have a room as well. And if it two matches, the room in the fire matches, and the room in the sprinkler matches, then we are checking whether on equal to false. on equal to false, whether the sprinkler is switched on or not. If it is not switched on, we need to turn it on. So that's the only thing that we are going to do. So if these conditions match, we found the correct room there. We found the correct room where there is fire and the sprinkler is not on. So our thing is to actually turn on the sprinkler. So this is a stateful KI session. So we will be able to use modify to modify the state of a particular object. So herein we are modifying the state of a sprinkler object by executing turn on method. There we were actually using Java syntax to directly access the field variable and then change its value here. Herein we are able to use the modify method. So what this modify method does is it makes the changes available to the rest of the rules, and the rule engine is aware that the object has changed. So that's what it does. So this modify is very important so that the rule engine becomes aware that the object got changed. And herein we are changing the state of the on variable, the boolean variable. Turn on will set on equal to true, and then just we are printing system .out.println sprinkler turned on. And so this is one rule. So when there is a fire, we need to turn on the sprinkler. So we found the correct room and turned on the correct sprinkler. The next rule here that says that when the fire is gone, turn on the sprinkler. So we turned on the sprinkler when the fire was there. Now we need to turn it off when the fire has been extinguished. So that's our job here. So we are having house, room, and we are checking the sprinkler room is equal to the room that we have here, on which on equal to true. If there is a room where there is on equal to true, and not fire. So this is a construct that we can use, not fire room equal to $room. And if see how this happens, we would be able to insert the data on the fly. When there was fire, we would have inserted KI session dot insert fire. We'll insert this new fire object of some room, and then when the fire is extinguished, we will also do that fire no fire. We would take the room out. So this is how we do it. And when not fire, when there is no fire object for this particular room, then this rule gets executed and it turns off the sprinkler. And the raise of alarm when we have one or more fires. If there is more than one fire object in the working memory, then we are going to raise the alarm. So we are going to insert the alarm into the working memory there, and then cancel the alarm when the fire has gone. So not fire and then alarm. So we would be able to delete the alarm object once and for all. So it's no longer in the memory, and we would set the alarm on to false. So we can do all these things by this rule. So each rule is interrelated to each other, and it all depends on the data, the fact that is applied into the working memory, and the rules are going to be applied on that fact. And since it's a stateful session, this is going to be like a ever going process. Whenever there is a data that is inserted, all the rules are going to be evaluated again and then fired upon again. So it's our task, and that does not happen automatically. It is up to us to fire a particular rule. It is up to us to fire a particular rule, fire all rules actually, not a particular rule. We cannot never execute a particular rule. We should be able to fire all the rules and all the data that is present in the working memory at that point in time. So this is about stateful session.